Okay, we are continuing with our STAAR review. Today we're going to be talking about scientific notation, and then we're going to be talking about functions and then system of equations. So the first thing we're going to look at is scientific notation. So it says the area of a piece of land is 4,951,000 square meters. How is this number of square meters written in scientific notation? Okay, let's first talk about scientific notation. Remember, when we're writing it in scientific notation, that means that our base number, our first number that we're multiplying, is going to be between 1 and 10, meaning it is going to be 1 point something and 9 point something. Okay, it's not going to be 10, it's not going to be double digits, and it's not going to be less than 1. So our base number that we're multiplying is going to be between 1 and 10. Okay, so the first thing we're going to do is we're going to rewrite this number. So we have 4,951,000, and then we're going to add our 3 zeros. Now, if you notice, when I rewrite it, I don't rewrite it with the commas, because when I add my decimal point, when I add my little loop-de-loops, if I have commas in there as well, it just gets to be a lot. Okay, so I rewrote that number, and when you rewrite it, you need to make sure that you rewrote it correctly, especially if there's a lot of zeros. Okay, so the first thing we're going to do is, remember, our base number is going to be between 1 and 10. So where we put this decimal point has to be between 1 and 10. So all of these numbers so far will not be between 1 and 10. But if I put it here, I have 4.951000. 4 is between 1 and 10, so we're good. So what I'm going to do is I'm going to rewrite all the numbers besides the zeros. Okay, so I have 4.951. Okay, remember, you're always going to multiply it times 10. Okay, now to figure out what the exponent is, you're going to count where the new decimal point is and where the original decimal point is. Okay, let's go back to the original number. If you notice, there is not a decimal point. Okay, so when there is not a decimal point, remember that decimal point goes at the very end. Our new decimal point is here so that the number is between 1 and 10. So from our original decimal point and our new decimal point, we're going to move and we're going to count. Remember, you're not going to start counting until after you move. So I move 1, 2, 3, 4, 5, 6. So my exponent is going to be 6. Now, what determines if this exponent is bigger or if it's positive or negative is we're going to look. Our original number is 4,951,000. That number is way bigger than this. Okay, it is way bigger than 4.95. So since our original number is bigger, that means our exponent is going to be positive. Okay, so our answer is 4.951 times 10 to the 6th power. Okay, now I will tell you this. I want you doing this first, and then if it's a multiple choice question, guys, I want you to match it up. Now, sometimes they won't take it all the way out these 3 places. Okay, you might just see it as 4.9. You might see it as 4.95. Okay, but just know it's all the same. Okay, so what I'm going to do is I'm going to pause the video, and what I want you to do is I want you to do the you do. Okay, so let's see if you're right. So hopefully the first thing that you did is you rewrote the number. But first, let's read the problem. Okay, there are a total of 463,100 books in a library. What is the value of the exponent? So guys, all we're doing is we're looking for the exponent when this number is written in scientific notation. Remember, if it's written in scientific notation, that base number has to be between 1 and 10. But first thing we're going to do is we're going to rewrite this number. So 463, I'm not going to put a comma, 100. Okay. The original number doesn't have a decimal point, so remember it's at the very end. Okay, so hopefully what you did is you placed the new decimal point so that the number would be between 1 and 10. So let me see. No, no, no. That would be 46. This would be 4.6, which is between 1 and 10. Okay, so here's my original decimal point. Here's my new decimal point. Okay, so I'm going to count 1, 2, 3, 4, 5. So I moved it 5 places. So what I'm going to do is I'm going to rewrite this. So I have 4.631. That's my base number. Okay, remember we're always going to multiply it by 10. Let's recount this. 1, 2, 3, 4, 5. So my exponent is 5, but I have to determine if it's positive or negative. So I went from 4.6 to 463,000. Okay, so this number is way bigger than this number here. So my exponent's going to be positive. So the question is not asking us to write in scientific notation. They want to know what is the value of the exponent. So our value of the exponent would be positive 5. So hopefully 5 is what you got for your answer. Okay, now let's look at the we do. Okay, it says the mass of a textbook is approximately 0.00165 metric ton. We're writing this in scientific notation, okay, which means we're making our base number between 1 and 10, okay? So first thing we're going to do is we're going to rewrite this number. And guys, remember, when you rewrite it, you need to make sure that you're rewriting it correctly. So we have 0.00165. So I'm just going to double check to see if especially when there's zeros, you want to make sure that you write it correctly, okay? So it matches. So if you notice, this number here already has a decimal point, okay? This number here is not between 1 and 10. So what I need to do is I need to move this decimal point so that it is between 1 and 10. So no, no, no. So I have 1.65. So that number is between 1 and 10. Okay. So I'm going to rewrite this 1.65. You're always going to multiply it times 10. Now we have to figure out what the exponent is. So here's our original decimal. Here's our new decimal point, and we're going to count 1, 2, 3. So my exponent is 3. Okay, I'm looking at this number here. This number is way smaller than this number. Okay, it's smaller than 1. So what I'm going to do, since this is way smaller than 1, my exponent is going to be negative. Okay, so my base number here, just checking, make sure that it's between 1 and 10, and it is. Because guys, sometimes you can eliminate answer choices just because, let's say you might have an answer choice like this. Okay, this base number here is not between 1 and 10, it is 16. So automatically, you know you can eliminate this one just by the base number. Another way that if it's a multiple choice question that you can eliminate answer choices is just looking at if your exponent is positive or negative. Looking at this number here, it is way smaller than 1. So we know it's going to be a negative exponent. And then another thing, you've got to make sure that you're counting and you're moving correctly. Okay, so I'm going to pause the video, and now I want you to do the you do. Okay, so let's see if you're right. First thing that you should have done is rewritten this number. So I have 0.001429. I'm just going to quickly check to make sure that I wrote it correctly. Okay, I'm writing it in scientific notation. That means I've got to have that base number between 1 and 10. So I've got to see where to move my decimal point. No, no, no. So I'm going to cover that up, cover my zeros. I have 1.4. Yes, that is between 1 and 10. So I'm going to rewrite my base number. So I have 1.429. Remember, you're always going to multiply it by 10. So I'm going to count my original decimal point and my new decimal point. 1, 2, 3. So my exponent is 3. Okay, now I've got to determine if this is positive or negative. This number here is way smaller than 1. So hopefully you made your exponent as a negative. Okay, so I'm just going to double check. My base number, yes, it's between 1 and 10 because I have 1.4. I only have one number in front of the decimal point. Okay, I'm going to carefully move my original decimal point to my new and count 1, 2, 3. That's my exponent. This number is way smaller than 1, so I know my exponent is negative. So hopefully this is what you got for your answer. Okay. Now let's move on to functions. Okay. Remember when we talked about functions, there was 4 different representations. We have one that's a table. Also, you see that you have ordered pairs. Then you have a graph. Then you have mapping. So these are the 4 different ways that you can see it. Remember with functions, your x cannot repeat. I'm going to say that again. The x cannot repeat. That means it doesn't matter what the y is. The x value cannot repeat. Okay? So let's look at letter A, answer choice A. Well, let's see what it's asking us. Which representation does not? So which one is not a function? Okay? But first, let's look at all the answer choices and see which ones are functions. Okay, so again, doesn't matter the y values. We're looking at only the x's. So we're only looking at these. Okay, I'm going to cross these out because it doesn't matter what these are. So our x values are 1, 3, 5, and 7. And we're going to ask ourselves, do any of those repeat? No, none of these repeat. So yes, this is a function. So I'm going to check it. Okay, now let's just skip over to answer choice C. Okay, this time they give us ordered pairs. So with the ordered pairs, we're only looking at the x value. And remember, the x value in an ordered pair is that first number. Okay, x comma y. So we're only looking at the first value. Doesn't matter what this is, so I'm going to cross it out. Doesn't matter what the second number is, what the second number is, what the second number is. Okay, and if you notice, all those y values that I crossed out, they're all the same. But remember, guys, it doesn't matter what that second value is. We're looking at only the x value. So we have 2, we have 3, we have 7, and we have 11. Okay, we're going to ask ourselves, do any of those repeat? Okay, no, none of those x's repeat. Since the x doesn't repeat, yes, this is a function. So I'm going to check that one off. Remember, again, we're looking at the one that is not. But before we answer any of these, we're looking at all the answer choices. Okay? When there is a graph, remember, with a graph, you do the vertical line test. And we've got to make sure that it only crosses through one time. So when we do this vertical line test, we're looking at this line here. When we do the vertical line test, it only hits once. When we do the vertical line test, it only hits once. So no matter where we do that vertical line test, it's only hitting once. Okay? So yes, this is a function. Okay? Now, if we're looking at dots, okay, remember we can't have dots on top of each other. Okay? So if I would write the ordered pairs for any of these on this line, none of those x values will repeat. Now, just because on those first 3, these are all functions, we're not just going to assume that this one here is not a function because we're going to look at it. Okay, so this one is a mapping. 2 things you look at. First thing, again, doesn't matter what this is. I'm going to cross it out. Doesn't matter what that y value is. Okay, first thing we're going to look at is, do any of these x values repeat? We have 3, 5, 7, and 9. Okay, none of those repeat. The next thing we have to look at is how many arrows leave from each one of those x values. Well, we have an arrow leaving from 3 and we have another arrow leading from 3. That means that that 3 is twice. I'm going to write that as an ordered pair. So 3 goes to 2, so that would be 3 comma 2. And then we have 3 leading to 6, so that would be 3 comma 6. The 3 repeats, that x repeats. So this is not a function. So the question is asking us which one is not a function. It's going to be letter D. Okay, so I'm going to pause the video, and what I want you to do is the you do. Okay, let's see if you're right. This time it's asking for which representation shows y as a function. So which one is a function? Okay, we're only looking at two things. We're looking at mapping and we're looking at tables. Okay, so letter A, I'm going to cover up the y values because it doesn't matter what those are. We're only looking at the x values. Okay, do any of those repeat? No, none of those repeat. Then the next thing you're going to do is you're looking to see how many arrows leave or how many lines leave each number. Okay, you notice there's only one arrow leaving each number. Okay, so this one looks to be a function. But guys, we're not just going to pick that one just because we see it, the first one, it's a function. We're going to keep looking at them. Okay, let's look at letter B. I'm going to cover up the y values because remember, it doesn't matter what those are. Okay, so none of those x values repeat. We have 0 and 1. But when you look at the lines, you've got 2 lines or 2 arrows leaving each one of those. That means if you would have written that as an ordered pair, it would be 0, 0 and 0, 12. That means since the x repeats, this is not a function. Okay, now let's look at the tables. I'm going to cover up the y values. So the x value, -1, -1, -1, -1, those all repeat. The x cannot repeat. So hopefully you didn't choose C because the x repeats, so it is not a function. Okay, and then the last one. We're going to cover up the y values. I'm looking at only the x. I have -4, 0, 1, -4. These two repeat. Remember, x can't repeat. This is not a function, so I'm going to cross that one out. So hopefully you picked letter A. This is the only one that the x does not repeat. Okay, let's look at the next one. Let's look at the we do. Okay, again, we have graphs, but now they give us a figure. Okay, not just a line. So you're going to do the vertical line test. It wants to know which one represents y as a function. So which one is a function? Remember, to be a function, the x can't repeat. So when it's on a graph, you're going to do the vertical line test. So I'm going to draw my line. Guys, it doesn't matter where I draw this line. It's going to go through it twice. Okay, that means since these two, it goes through twice and these dots are on top of each other, that means they share the same x value. So that means this is not a function. Okay, let's look at the other graphing one. Okay, we have another figure. I'm going to do my vertical line test. So I'm going to do it here. It hits here and here. That means it hits twice. Okay. Also, I'm going to draw my vertical line test here because sometimes you may just have a single line like this. Okay. It's hitting all the way down. That means it shares the same x value. The x cannot repeat for it to be a function. So this is not a function. So neither one of those graphs are a function. Okay. Let's look at the mapping. I'm going to cover up my y's because remember, doesn't matter. I'm going to look at my x values to see if those repeat. I have -11, -14, -17, -20. None of those repeat. Okay, so we're good on that. But then we have to look. We have one line leaving, one line leaving, one line leaving, one line leaving. Since there's only one line leaving each number, this is a function. None of those x's repeat. But we're not going to stop there. Okay, we're going to look at the last answer choice. We're going to cover up the y's because remember, doesn't matter what they are. They can all be the same. or they could all be different. Doesn't matter. I'm going to cover them up. I'm first going to look, do any of these numbers repeat? Okay, no, none of them repeat. You've got one line leaving 16, one line leaving 18, one leaving 20. But if you notice, you've got two lines leaving 20. You cannot have two lines leaving an x value. That means it repeats. That means this is not a function. So the only one that is a function is this one here. Okay, so I'm going to pause the video, and what I want you to do is I want you to do the you do. Okay, let's see if you're right. It says which one represents y as a function. That means which one is a function. Okay, so we're looking at this line here. So hopefully you drew the line so that way you did the vertical line test. It's only hitting once. So yes, that's a function. Hopefully you didn't stop there. Hopefully you looked at the other ones. Okay, let's look at letter B. Okay, I'm going to do my vertical line test, so I'm drawing my line through. But if you notice, it hits here and here. If it hits more than once, that means it shares the same x value. It's not a function. So hopefully you didn't pick that one. Okay, let's look at answer choice C. I'm going to do my vertical line test. It hit here and here. That means it hits twice. That means it shares the same x value. So hopefully you didn't pick C because that's not a function. Okay, and letter D, here's my line. So I'm going to do my vertical line test. And guys, it is hitting all the way down. That means it is sharing the same x value. It cannot share the same x value. That is not a function. So hopefully you pick letter A. Okay. Now the last thing we're going to look at is system of equations. Guys, this should be pretty easy. Okay. Because all you're doing is you're looking at these two lines that represents an equation. And you're wanting to know which one is the solution. So guys, the question is asking, which ordered pair is a solution to both equations? So all you are looking at is you've got this line that represents an equation, this line that represents an equation, and all you're doing is you're looking to see where they cross, where they meet, okay? And you're writing that ordered pair, okay? So you start at 0, 0. You come over here because remember the x value is first. So you go along the x-axis. So you go over here to -3. And then you go up to +3. So your ordered pair is -3, 3. You're going to look at your answer choices. And it's letter B. Guys, it doesn't matter what any of these other ordered pairs are because that's not where they cross. You're literally looking to see where they cross. Okay? So I'm going to pause the video, and I want you to do the you do. Okay, let's see if you're right. It's asking, what is the x coordinate? So it's not asking for the ordered pair. They're just wanting to know the x of the ordered pair. So when you write your ordered pair, remember the x value is the first number. Okay, so you're literally looking at the two lines and you're looking to see where they intersect. And guys, they intersect at the origin at 0, 0. But you're only looking for that x value, that first number, which is 0. So hopefully you picked letter G.